Hi guys, I'm going to help review with you some of the things you'll need to know for the rock cycle quiz. So first of all, you need to know how each rock type forms and what some common characteristics are. So I'm going to go through those really fast. First we have sedimentary. This is an example of a sedimentary rock. You can see, I'm trying to find a side that shows it. You can kind of see those layers. You can see horizontal lines. So if you see bands or layers, that could be a characteristic of a sedimentary rock. Sometimes it's got a grainy, sandy texture. And then sometimes you can even see little pieces of rocks or pebbles that are in the sedimentary rock. And sedimentary rocks form by sand and dirt and sediment gets carried along in a river or something. It gets deposited, that's deposition. And then compaction is like pressure, right? So it gets pressed down by the weight of water or other sand on top of it. It gets compacted and cemented together. So compaction and cementation presses that rock down. So pressure causes sedimentary rocks to form, but there's no heat involved. It's just pressure pressing those sediments together, compacting them and cementing them together. Another word you need to know that has to do with that is sedimentation. Sedimentation is when there's a bunch of dirt in water and then that dirt settles down. That's called sedimentation. When dirt settles down out of water, it settles to the bottom. And then metamorphic rocks are, like, here's an example of a metamorphic rock. You notice it has these ribbon-like layers. So it's different than the layers in the sedimentary rock, which are just straight across and horizontal, right? This has ribbon-like layers. They sometimes they bend, right? That's because heat and pressure has changed and chemically altered this rock. So it probably used to be sedimentary, maybe it was igneous, but it was a different type of rock, and then it was deformed by heat and pressure. This rock got pulled under the surface of the earth, and the heat and pressure down there changed it, morphed it into a metamorphic rock. So ribbon-like layers like this, and also you can't really see, I don't think, in this video, but it's also got some little crystals. Crystals are another characteristic of metamorphic rocks, and make sure you know that word deformation. It's just a fancy way of saying this rock got changed or deformed by heat and pressure. So deformation causes metamorphic rocks. And then igneous rocks, they're formed by lava, which comes out of a volcano cooling. And there are several characteristics they have. So this is an igneous rock. You can see it's got a nice glassy surface. That means that it probably cooled pretty fast. Another igneous rock is this one. You can see it's got lots of air bubbles. If it has air bubbles, that means it cooled really fast, so fast that the bubbles didn't have time to escape out of the magma or the lava before it cooled. So this one cooled fast. This one with a glassy surface also cooled fast. Now granite is an igneous rock that cools more slowly. You can see there's lots of crystals in this granite, and those are formed because it cooled slow enough that it gave time for the minerals to find each other and form crystals. So if you see crystals in an igneous rock, that means it cooled really slow. If you see a glassy surface or air bubbles, that means it cooled pretty quickly. So those are some characteristics of igneous rocks. Okay, and then also, so I mentioned for sedimentary, pressure, but no heat causes a sedimentary rock. Now for igneous rocks, it's cooling magma, so there's a lot of heat because that melts the rock into magma, and then when the magma cools, it's an igneous rock. But there's no pressure involved in igneous rocks, or at least not very much. It's mostly heat. And then for metamorphic rocks, it's both heat and pressure because it gets pulled under the surface of the earth, and the heat and pressure of the layers down there deform it into a metamorphic rock. Okay. You also need to know that matter is never lost. Even if a rock gets weathered and pieces of it come off and are eroded away, they still exist. They don't disappear into thin air. They're not part of that rock anymore, but we say that they don't get lost. They still exist, right? So matter is never lost, and also energy is never lost. If you remember, we did those energy stations learning about the different types of energy. It just gets transferred to another type. Like if I hold up a bouncy ball, it's got potential energy. When I drop it, the potential energy changes into the energy of motion, which is kinetic energy. Some of its energy gets transformed into sound energy or heat energy. Some of it pushes on the air molecules around it to give energy to those air molecules instead. So that's why the ball starts bouncing more slowly if you let it keep going. But the energy just transforms into different types. It doesn't disappear into thin air. So same with the rock cycle. Energy is never lost in the rock cycle. It just transforms to different types. So the two sources of energy for the rock cycle are the sun, because the sun heats water, the water evaporates, makes a cloud, and then it rains, and that rain can weather away rocks, and then we get sedimentary rocks forming, right? So the sun is one source of energy for the rock cycle, and then the second source of energy is the inside of the earth. That melts the magma, it melts rocks into magma to form igneous rocks, and it causes the heat and pressure to form metamorphic rocks. So the two sources of energy for the rock cycle are the sun and the inside of the earth, and energy is never lost, just like matter is never lost, okay? So hopefully that was helpful. Hopefully that helps you be successful on your quiz. If you have more questions, please ask me, because I want to help you be successful. Good luck on the quiz.